When you get a paper cut, you don't have to manually tell your body how to fix it. Your system senses the damage, triggers an immune response, and stitches itself back together. Software, on the other hand, just crashes. It relies entirely on human intervention to diagnose and repair the damage. By the end of this tutorial, you will build a custom AI agent that autonomously detects broken builds in your pipeline, writes a code patch, and verifies its own repair. To build this workflow, you need 3 foundational elements: a functioning code repository, a CI/CD platform like GitHub Actions or Jenkins, and access to an LLM API. Transitioning to a self-healing architecture removes you from the loop of manual, reactive firefighting. Instead, you design systems with proactive, autonomous resilience built right in. This diagram maps biological functions directly to software components. It relies on 4 parts. Observability tools act as sensory inputs. The LLM functions as the brain. Repair scripts form the immune system, and Git version history acts as cellular memory. Step 1 is configuring the sensory input. You need to update your CI/CD YAML file to trigger a specific automated response strictly when a test failure occurs. Once triggered, your pipeline needs a script that uses regular expressions to extract the exact stack trace and the code defs from your latest commit. Capturing this highly specific injury report is critical. Without it, the AI is guessing blindly. Supplying the exact diffs and stack traces transforms raw pipeline errors into actionable diagnostic data. Next, we feed this injury report to the LLM, which acts as the diagnostic brain. However, if you only provide the error log, the LLM lacks broader codebase context and will likely hallucinate an incorrect patch. To solve this, we use an abstract syntax tree, or AST. This parsing method converts raw, flat text code into a hierarchical tree of structural logic. Injecting AST data gives the AI the exact programmatic rules it needs to understand your codebase. With the context prepared, you construct the prompt template to identify the anomaly by passing it the extracted stack trace and AST structure, asking it to output a code patch. The pipeline then takes the LLM's generated code patch and automatically applies it to a newly created temporary Git branch. The agent must never be granted permission to commit code directly to your main branch. Strictly sandboxing the AI's repair attempts isolates your risk. This guarantees that an automated immune response cannot accidentally introduce a catastrophic regression into your production environment. This flowchart details the verification loop. AI-generated fixes must be validated here. You run full unit tests against the sandbox branch. If tests pass, the agent creates a pull request for human review. If they fail, the error loops back for revision. You must hard-code a strict retry limit into this loop, typically 3 strikes. This prevents the AI from burning through compute resources in an infinite testing cycle. This verification loop shifts the burden of trust away from the AI's raw intelligence and onto empirical testing. It guarantees that developers only spend time reviewing code that has already proven it works. The end-to-end workflow is now complete. A broken commit enters the pipeline, the agent creates a branch, writes a patch, verifies the fix, and outputs a ready-to-merge pull request. This image contrasts the manual method of vibe coding on the left with the structured reality of agentic coding on the right. You have built an agentic system. Your daily role is no longer writing boilerplate, but providing strategic oversight and judgment on these automated solutions. You can find the complete configuration scripts and prompt templates in the description below to build your first healing agent today. Autonomous self-healing pipelines do not replace software engineers. They eliminate operational toil, unlocking your time to focus on genuine architectural innovation.